Sweet dog.
So first we're going to go to File and start a new project.
Okay, the first thing we need to do is we need to get the run that represents the PLC and the input and output card for the PLC. So to get the run, we're gonna go down to we'll go down to ladder for Allen Bradley, and we'll select the run right here and drag it here. And then we need to get the input and output cards. I'm gonna drag a switch on here as well because I know that we'll need this switch. So next, I'm gonna go down to PLC cards, which is under electrical control line, and I'm going to drag the input card, put on this side, and the output card, which will go on the other side. Following this, I'm going to go down and get the power source, which we will need a ground for the common, and also we'll need 24 volts for the top. On both of the cards. Following this, we are going to now create a circuit. So we need then two switches. So I go to switches here on the electrical control, and I'm going to select the normally open toggle switch, and I'll grab two of these. We're not going to put the alias right now. This is the reference. Okay, so then also we're going to grab some output coils. So I'm going to go on the output components, and I will select a solenoid. Now this is just representing our light that we are going to look at in a second. Okay, so we're not going to put the alias right now. The next step is to construct the circuit. So we'll construct the circuit on the card, and then we'll construct the circuit on the PLC. So what we're going to do, we are going to use 24 volts as the power source, and we're going to connect the two switches to the first two ports of the input card of the PLC. Okay. The common port goes to ground. On both cards. So we have done the first card, we're going to do the second card. And the ground goes to the common. So the next thing we need to do now is to wire up the circuit. Now we're going to do an AND gate. So these two switches, we're going to have an output for AND, and we're going to have an output for OR, because this lab entails creating or having a circuit for all the gates. So I'm just going to copy and paste. I need two here in series, and I need two here in parallel. Okay, let's get the coil. So if I come back to Allen Bradley, I'm going to go back to the output energized coil. So this is what represents our output. I'll put one here. I'll not put the alias right now, and I'm going to put the other one. Okay, this is the wrong one. Copy this one and just paste it here. Makes it easier. Now to wire it, just connect the red dots, and this will appear. And again, this is the OR gate, so they're in parallel. And we are done with the wiring. The next step now entails us actually putting the reference for each component. So here I'm going to select iron 0 on the card for this switch. So this switch is representing the connection of the input card iron 0. So I double click on the switch, and then I go to and I search for iron 0 and double click on iron 0, and it will appear there at the bottom here with the association, and then you close it. Same thing for this one. This is iron 0 again. I double click on the switch and I select iron 0, double click on iron 0, it appears at the bottom, and it's ready, so I can close it. Now this one is going to be iron 1. So I find iron 1, I double click on it, it is associated here, and we do the same thing for this one. Iron 1. Now for the output, it's going to be associated with the output card. So I can double click on this one and select 0 for this one. So this is for the end, and then for this one I will select 01. Okay, so it's already associated with it. Now I'm going to just put some names for these switches. So let's double click on this one, on the switch itself. See if we can zoom in on it. So this switch, let's call it switch 1. And this one, I'll bring it down. This one, we'll call it switch 2. Oh, well, switch 0. And this one we can call it light 1, and of course this is just for naming. This light 1. Light 1. And this one is light 0 at the top. So I'm going to bring this one down by clicking it and dragging it down with my arrow key. And this is light 0 here. Alright, so this, I have completed it now. Let me zoom out and let's run the simulation. So I hit the play button at the top here where it says normal simulation. And if I close switch 0, I can see that switch 0 is active here. It's active here as well. And because this is in parallel with the output, we can see that the light 1 output is high. If I close switch 2, now both of them are active now. And so this one is high. So this is the AND output is high. So you can see what you can do here. Put all the rest of the gates, the NOR, the NOT, the exclusive OR, etc., etc., all of them in this run. And you can do that by expanding this. This can stretch right down, right? So you can add more and more rungs. So when you're done, you will save, of course, save the project. Save project as, so I'm going to call this one Project AC 2019 Test 11. Save. This needs to go in your lab report. Ensure that you have a printout of this right here with all your gates. Now you need a printout of this with all your logic gates, and hopefully if you are able to complete your decoder, you need the printout of the gates with the decoder and the decoder circuit. And this is it. This is where we stop for today. Thank you so much. This is Muhammad, my friend. Muhammad. Okay, please, I hope that this video was helpful and that you can have the steps that you need to actually use the software to complete your lab. If you have any questions, you can feel free to see me. Thank you. Thank you to Al Zahar for recording this video. I really appreciate it. Thank you.